Okay, last thing we're going to do with numbers in scientific notation is we're going to divide them. So very similar to the multiplying scientific notation, let's look at some similar problems we did earlier in Chapter 7. You can see here I have written here 4x to the fifth over 2x squared. Here, if you do this, you divide these. So 4 divided by 2 is 2. That stays up top. And then you have the same base of x. So if you have the same base of x there, this is where you subtract the exponent. So 5 minus 2 is 3. Now the exponent stays in the top because that's where it's bigger. So what we basically proved here is now if we divide numbers in scientific notation, these are like the actual numbers. So you actually divide the numbers, which you're going to use your calculator for, and then now with the exponents you subtract them. And the exponent should stay where it's bigger. Okay, so if I do the first one, I'm going to divide these numbers. So I need my calculator for this. I'm going to do 5.1 divided by 1.5. That gives me 3.4. I like that number because there's just one non-zero digit to the left of it. Then I just subtract these. 6 minus 2 gives me 4. So this is times 10 to the fourth. And that's it. That's our answer. Okay, now I'm going to do 2 and 3. It's going to be a little bit more difficult because we're throwing negatives in there for the exponents, but we're still just going to subtract. Now let's divide this. 3 divided by that 1.2. So 3 divided by 1.2 gives me 2.5. Again, I like that number. Now when I subtract, I'm going to do negative 2 minus 3. That gives me negative 5. So this is just times 10 to the negative fifth. Now I'll leave it like that. These ones in scientific notation, you can have a negative exponent. I know before, in the beginning of Chapter 7, we said you never are left with a negative exponent. Now you can in scientific notation. You know, like, you could bring this down here, so you're going to have 10 to the fifth in the bottom, which is just like saying 10 to the negative fifth. Okay, let's do number 3. So number 3, I'm dividing these numbers first. So 7.2 divided by 4 gives me 1.8. And I like that number. Just one non-zero digit to the left. And then when we subtract, we're doing negative 5 minus, don't forget this negative 3. So this is where it can get a little tricky. If you're subtracting a negative, you add it. So negative 5 plus 3 is negative 2. So it's times 10 to the negative 2. So that's our answer. Okay, let's skip down to number 5. Now number 5, we're going to get a decimal now that's not going to be in between 1 and 10. So at the end, we're going to have to rearrange the decimal point. Okay, so 5, I know I'm going to divide the numbers first. So 1.17, I'm going to divide that by 5. So that gives me 0.234. I don't like that number because it's not between 1 and 10. And then I subtract the exponents, so I'm going to have 2 minus negative 1. Well, that becomes 2 plus 1, so the exponent's 3. So this is times 10 to the third power. Okay, and that kind of makes sense because, you know, if you made this negative 1 positive, you move it to the top, and it winds up becoming 10 cubed. All right, so we're not done now. Now, this decimal kind of screws it up. Now I want to move this to the right. So I want to move this to the right so I get 2.34, so that number's in between 1 and 10. So when I do that, I move this to the right, it becomes 2.34. Now it's kind of the opposite. If I move this to the right one, I'm making this decimal, 2.34, making that bigger. So what we actually have to do, if I move this to the right one time, I have to subtract 1 from the actual exponent. So it becomes times 10 squared. And again, you could check it if you actually wrote out the actual number for this. It's what, 234? Same thing here. If I looked at this, if I moved it, it's times 10 cubed, so if I move this to the right 3 times, this still equals 234. So it's the same thing, but I want that decimal to be in between 1 and 10. So that's pretty much it there. So main thing is what you filled in. You divide the numbers, and then you subtract the exponents. Good thing with this, in dividing numbers in scientific notation, you can be left with exponents that are negative.